well as some of the postgraduate data science programs, as well as supervising. So I'm going to touch on the idea of critical thinking skills in our statistics programs, and particularly identifying that there's definitely a shortage in that in our students. So we know that specifically in statistics, these critical thinking skills are imperative, more so than, say, other fields like accounting or HR, say, for instance. But they are particularly important whether the student is going out into industry or pursuing postgraduate studies, because they need the ability to analyze data, make informed decisions, and solve complex problems from various domains. Also in industry, one of the key roles of a statistician and data scientist is to analyze and interpret data in a way that can directly impact business decisions. So this not only requires the ability to critically evaluate data quality, assumptions, and the implications of the findings, but also to be able to apply the correct methodology to the specific problem to be solved. But now with this current data-driven age that we're in, where there's an influx of information at our disposal, this has increased the demand for these critical thinking skills. But it's also necessitated an evolution in how statistics is taught to better meet the needs of industry, as well as develop those critical thinking skills. But the statistics curricula needs to be adapted to prepare these students, not only as academic statisticians that maybe will be teaching future statisticians or contributing to the development of statistical theory, but also as applied statisticians and data scientists that are capable of addressing real-world challenges. Now, from my experience, I know at UKZN, we have tried to adapt our curriculum to meet the needs of industry, but there is definitely still a gap in how the students or the type of students that are graduating and what is expected of them in industry or even in furthering their statistical education in, say, postgraduate studies. And I think this gap then definitely needs to be addressed. And one of the reasons maybe for the gap is that there is a change in the generation of students that we are seeing in the universities. And when I did a bit of research on this, I actually noticed that, so this was my hypothesis, that the students themselves have changed. And there's actually been a large body of literature that has discussed these changes in the generation of students entering universities, especially post-COVID. And these have influenced their learning habits, their expectations, and the needs of those students. So this change has also coincided with a noticeable decline in critical thinking skills in the students. And this is highlighting then the need for educational approaches, so the curricula, the teaching methodologies, and the way we assess to adapt in order to foster deeper analytical abilities alongside the evolving industry demands. There were several other factors that were mentioned in the literature that contributed to changes in these students. So there's been a noticeable surface learning tendencies, where the shift to online during COVID to a more passive form of learning, where the students focus on completing tasks rather than engaging deeply in the material. Also, assessment-driven learning, students are focusing on just the grades, getting the grades, rather than actually absorbing and retaining that information. Then there's a lack of exposure to critical thinking in early education. And I think that's particularly noticeable in South Africa, where our young school-going children are exposed to so much content where they touch on a little bit of a lot. So they're not taught from the start to engage fully and go deeper into the material. Also, there's time restrictions, and there's continuous assessments where they just don't have time to absorb what they're being taught. Then there's also been changes in cognitive engagement. So the ease of accessing information online has led to this surface level engagement where students prioritize finding quick answers rather than actually understanding the underlying concepts. And there's also been multitasking encouraged by digital devices, and that has affected students' ability to focus deeply on complex problems. And that just results in a cognitive overload, which really just makes it harder for the students to engage critically. And then, of course, the educational practices and curriculum that we currently follow, that also just translates to maybe a lack of emphasis on critical thinking in the curriculum. So there are various ways that we can foster critical thinking skills. But this requires a balanced approach between integrating and linking the theoretical understanding as well as the practical application. So emphasizing a deep comprehension of statistical theories, but beyond just pad fashion learning and regurgitation, is crucial. And I've seen this where our undergrad right up to our honors, because of the type of curriculum or the way in which they are being assessed, they rote learn, they parrot fashion learn, they get good marks for the exams, and then it comes to maybe studying or furthering, going into a master's degree, and they cannot even do any self-learning or understand what they're learning and how to apply it, because our curriculum has not allowed them to gain that skill. But equally important is focusing on how that theory is then applied, as well as the interpretation of those results and analyses. And that then just can ensure that the students not only grasp the theoretical concepts, but also can apply them effectively and thoroughly in real-world contexts. But of course, achieving this balance requires an update to the curriculum, as well as the way in which it's taught and assessed. Now, there's multiple challenges that I've at least come across when I've been trying to implement this, at least in my third year level statistics module, where there's resistance from the senior academics who are accustomed to the traditional teaching methods, as well as the traditional curricula. And of course, we have constraints where we're already overwhelmed with our workloads and large class sizes. So trying to adapt our curriculum and our methodologies, it's a challenge. So there are several formative assessment approaches that can develop and evaluate the critical thinking skills. Obviously, in addition to the traditional 3-hour exam, which unlike for Michael, it's mandatory at UKZN. So we've heard about Michael's approach, and I think it's fantastic, and I would love to implement that as well. But in the case that you can't, there's other ways that we can try and assess the students formatively to try and just advance their critical thinking skills. One is the open-ended problems, where they require students to explore multiple solutions or approaches. Case studies, project-based assessments, and then critical reviews of research articles. So I have in my third year level, which is my third year module, which is taught on Westville campus by myself and on Pietermaritzburg campus by another senior academic. In my module, I have implemented a small mini project which the students need to work on. And at one stage, I also gave them a research article to read through and answer various questions on that. And I did see a noticeable change in those students that had done my module going into their honors compared to the cohorts in Pietermaritzburg. But it is hard work. especially when you're working with large classes. It's much easier just to set 2 tests for the semester and leave it at that, as that's the bare minimum, versus add projects and additional assignments to that. But in saying that, it's also for the traditional question-based tests and exams, we should enhance the way that questions and calculations are framed to focus on testing the students' understanding of the concepts, merely than just simply testing their ability to follow mathematical formulas. And I've seen this firsthand, where the way in which our students, even at 3rd year, are assessed, it's just plugging into a formula. And that's testing their mathematical ability, not their statistical ability, not their critical thinking skills. So there's definitely this gap that needs to be addressed. And that's just simply by maybe changing the way in which we ask our questions, or the way in which we assess, just small things that can help that. And then this is just an example of what I mean in terms of the way that we could think about rephrasing our questions. So if we're wanting to fit a simple linear regression to look at a test result based on the number of hours that are being put into studying for that test. So we're wanting the students to calculate that estimated regression coefficient. There's a couple of ways that we can ask that student to get that answer. So one way is just outright calculate the regression coefficient, or calculate the estimated gradient of the line, or calculate beta at 1, or calculate the estimated effect that studying has on the test result. So out of these 4 different ways of asking for the same thing, which one is likely to require students to have more thorough understanding of that material, of the concepts of what calculating a regression coefficient actually means? In that case, I believe it would technically be 4. And this is just a very simple, maybe even a 1st year level type of question, just to get my point across, where we should be focusing on a deeper understanding of what these calculations mean, and what's the consequence maybe of what they're achieving, rather than simply a mathematical ability to plug in a formula and get an answer. So that was just from my experiences of what I'm currently going through with my students at my university. Thank you.
Awesome experiences. Thanks a lot.